So we're going to look at how to calculate this limit numerically, algebraically, and graphically. So first, let's look at numerically using the graphing calculator. And we're going to go to our y equals. And what we're going to do is we're going to enter this in as a graph. So in my y equals, now I do need to separate the numerator and the denominator with parentheses. X squared minus 1 divided by x minus 1. Now I'm not trying to graph it right now. I want to do this numerically, and what I'm going to do is I'm going to use my table. So first thing we've got to do is make sure our table is set up correctly. So I can go to second table set. I want my independent to be on ask. Alright? And it doesn't matter where my table starts because I'm going to put that in for it. So here's my table. Now remember, just as a reminder, we were looking for the limit when x gets near 1. So we're going to pick points around 1. For instance, if I put in 1, I get an error. Well, it's because of that negative 0 in the denominator. So I'm going to pick some points around 1. How about 1.1 and 1.01 and 1.001? Alright, so those are all on the right side of 1. Well, looks like it's getting closer to 2. So we're going to check the other side. So 0.9, 0.99, 0.999. So as we come in from the left and the right, we're getting closer to 2. Our y values keep getting closer to 2 as our x values get really close to 1. So it looks like numerically this limit is going to be 2. Now what we're going to do is we're going to verify that algebraically and then take a look on a graph. So algebraically, the way we might solve this one is notice that the numerator is going to factor. We have difference of squares. So x squared minus 1 is going to factor into x minus 1 times x plus 1 over x minus 1. Now because we're looking for a limit, we're just talking about the function's behavior around 1, not what its actual function value is, because this one we saw doesn't have a function value at 1. So one thing we can do is we can cancel out this x minus 1, and then we can see if we're able to calculate the limit as x goes to 1 of x plus 1. Plugging 1 in for x there, we get 2, and verify what we saw numerically. Now, I've already put this in as my y equals, so if I do a zoom 6 to get into a nice standard window, I can see my graph there. Alright. We'll look at another copy of a graph, but notice what's happening as we get near 1, it's about 2. Now, the graphing calculator can't show a hole. So, let's bring in a little bit bigger graph. So here's the graph of our function that we just saw in the graphing calculator. Remember what we care about. We're going towards 1 from the left and the right. We want the behavior around 1. Well, as I come in from the left, my y values are going to 2. Same thing we saw numerically. As I come in from the right, my y values are once again heading towards 2. So graphically, we also see that the limit of f of x at 1, as x approaches 1 is 2, even though f of 1 does not equal 2 because we have a point of discontinuity there. The behavior of the function says that our outputs are going to go to 2 as our x approaches 1.